This is a new video on binary logistic regression in R. As I mentioned in my previous video, that is in video number 562, that in the next video I'll be using binary logistic regression model in R, where my independent variable will be a categorical variable. In the previous video, I used independent variable as a quantitative variable, and that was age. In this video, I am also using a binary logistic regression model in R, but this time instead of quantitative variable, I am using a categorical independent variable in my regression model, and I'll interpret the results as well. Let us suppose we want to estimate the impact of a patient's sex on the presence of heart disease. Then in this case, sex will be our independent variable, and heart disease will be our dependent variable, with 0 meaning no disease and 1 stands for disease. So now I will go to R. This is R, and I have already opened my data set, and my data set is again DAT, and previously in the previous video I explained M1. M1 was my binary regression model in which I used as my independent variable, that was quantitative. Now I am going to estimate M2. This is another model, and here I am using also a binary logistic regression model, but this time instead of a quantitative independent variable, I am using sex as a categorical independent variable. So first of all, I would like to estimate the model, and let me click on this. So the model has been estimated. Now I would like to show the summary results of this model. This is the summary results of this model, and it uses a GLM formula for heart disease which is regressed on sex, and family is a binomial. These are the coefficients of the first. This is the first one is minus 1.0438 is the coefficient of the constant, and 1.2737 is the coefficient of sex, where sex is a categorical variable. Now this time the interpretation will be a little bit different than before. If I show you more the results of this model, here are. Now we can't interpret the estimated coefficient of a categorical variable like the one that we did in our previous video, when our independent variable was quantitative, that was age. In order to see what does this mean, first of all we would like to see the p-value of the coefficient of for sex, which is very much less than 0.05. so we conclude that the sex is significantly associated with the presence of heart disease at the 5% significance level. Moreover, when looking at the coefficient of the sex, that is beta 1 hat, that is which is equal to 1.274, we can say that for male the odds of developing a heart disease is multiplied by a factor of e raised to the power 1.274, and that is equal to 3.574 compared to females. In other words, the odds of developing a heart disease for males are 3.574 times the odds for female. This means that the odds of developing a heart disease are 3.7 minus 3.574 minus 1 multiplied by 100, that is equal to 257.4% higher for male than for females. So it means that the odds of developing a heart disease are 257.4% higher for males as compared to females. These results again make sense, as it is known that men are more likely to develop a heart disease as compared to women. The interpretation of the intercept, that is beta hat uh, beta naught hat, is equal to minus 1.044, and this is similar to the previous section in the sense that it gives the probability of developing a heart disease when the other coefficient beta 1 is equal to 0. So in our case, beta 1 is equal to 0 means that the patient is female. Therefore, the probability of developing a heart disease for women is given by this formula, e raised to the power the coefficient of model 2, where 1 is female, whole divided by 1 plus e raised to the power coefficient of M2 model, and 1 is for female. So if I click this, if I run click or I hit run, then the this is the probability of a woman developing heart disease. So the probability for a female heart disease is 0.26. We will also estimate or predict probability for a male to develop heart disease, but that will be a little bit later. Now we will notice that a univariable binary logistic regression with a qualitative independent variable will lead to the same conclusion like chi-square test of the independence. We have already discussed chi-square test results in our previous videos, but here is the formula for the contingency table of heart disease and sex, and this is the chi-square test. So if I click on this, this will give me the chi-square test result of the contingency table between heart disease and sex. The chi-square test value is 21.825 degrees of freedom 1, and the associated p-value is much less than 0.05. So we reject the null hypothesis of independence so we reject the null hypothesis of no association between the two variables, and thus we conclude that there is a significant association between the presence of heart disease and sex of the patient, because the p-value is less than 0.001. However, the advantage of a univariable logistic regression over a chi-square test of independence is that it not only tests whether or not there is significant association between the two variables, but it also estimates the direction and strength of this relationship. And prediction can be made with the predict function. Suppose, for example, we would like to predict the probability of developing a heart disease for male, then we use this formula. Predict M2, this is my model 2, new data is equal to data frame, sex is equal to male, and type is equal to response. So if I click run, it will calculate the predictions, and let me click on the predict, then it will give me a probability of 0.557. So based on this model, it is predicted that a male patient has a 55.72% chance of developing a heart disease, which is much higher as compared to the probability or the percentage of heart disease to be developed by female. So ladies and gentlemen, this is how we can use a univariable binary logistic regression to predict probabilities for a categorical independent variable. I hope this was quite helpful for you, and if you like this video, kindly share this video with your colleagues maybe your students and friends, so that this could reach to the maximum possible number of people. Kindly subscribe to the channel and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll be uploading for you. Thanks for watching, and see you in